Hello guys, this is Thomas Ken. So today is also tutorial for beam analysis. So it's about shear and bending moment diagram that we have done before. Different examples, so stay with me and I hope you are going to enjoy this video. So let's start from this. Our today's beam looks like this. We have point A and point C in which it's supported, and also we have 8 kilonewton point load, and we have 10 kilonewton meter which is distributed load through the whole beam. So stay with me, we are going to solve this. Let's go to SolidWorks. Okay, so let's draw this new part, sketch, front plane. I think this is let's turn this this was in, so we have to make it meter as our dimensions are given in meter. So this one was I think 2, right? So let's check it before we write our dimension. Let's check it. Yeah, 2 and 8 meter. So let's make it this 2 and let's make it this 8. And then as I showed you in the previous video, let's go to element and structural member and let's select this one. We have this thing, we don't need this, so let's go to the sketch of this and let's delete the whole thing. So let's let's draw our own. Let's make like this, guys. And the same thing here. In the longest part, if you say it, if you make normal, still we have z index, right? There's z, there's x. So we want this x, right? But this is, we don't want to be z. We want it to be y. Just to make it simple in the result demonstration. We don't have any reason for this. So let's go to this and edit feature. And let's rotate this thing 90 degrees. Now we can check it. As you can see, we have there in it, right? So now it's time to go to simulation, new study. Let's make it this beam and analysis 2, right? So we have 3 points. What does it mean? We have point A, we have point B, and we have point C. Now let's apply the reaction forces. Let's think they are roller, so there is no enough information here, but let's think they are roller supported and let's apply these reaction forces. But before that, don't forget to specify or assign material, because SolidWorks will not allow you to simulate if you don't tell him the material type. But in real world, we don't need material to make this calculation. So apply, close. Let's go to fixtures. But one thing that I forget here is, if you want to know whether it's beam or not, yeah, you can check it here. It's beam, right? It's also rigid. You got my point? Yeah. You can also check for this material also. This is beam. So we don't have to worry about it. Most of the time, if it is beam, it's like you can check it SolidWorks by itself, but if it is not a beam, if it is truss, you have to uncheck it by yourself. We will see it when we go into our truss tutorial later. So let's go fixtures and let's now the fixed geometry. We have this one and this one, right? At both of the end points. Let's make it this point and in the front plane, right? Are you with me, guys? I hope you are doing well, enjoying the lesson. So let's apply this reaction force and let's increase the size. As I told you, the maximum is 500, so this is our reaction. And here we have the other end, which we are going to apply the reaction force. Sorry, let's make this and let's select this front plane and let's apply the load to a part. And the last thing is this 500, right? So we have this reaction force. We're done. What else do we have now? We need to apply this 8 kilonewton, which is at point B. Where is point B? Let's rotate this here. How much was it? 80 kilonewton, right? 80 kilonewton. So let's go force and let's make it point. So our joint is this one. Let's go to front plane across, and we have to reverse it. How much was it? I'm not good at remembering numbers. So 80,000. 80, 1, 2, 3, 4, right? So let's just increase this to make it more visible. Now we're left with the distributed load, 10 kilonewton meter or 10,000 newton per meter. So let's go and we have to make like this. So what we have to do is let's go to external load force and let's select this surface, the whole, and this surface, right? So the plane is the front. Here you can see, let's make it per unit length, and let's make this. How much was it? 10, 1, 2, 3, 10,000. Let's reverse the direction. This is our distributed load, right? Let's increase this to 500. So here we go. We got this. So I think we're done. Let's see what the results are going to be. Are they going to be equal or are they going to be different? Let's check it. Run this study. Let's start from the reaction force. This result force. So looking asking us to tell him the joints where the reaction forces are located. So let's update. So here we have 114 and here we have 66 kilonewton, right? I think they are equal. Here we have 114, here we have 66 kilonewton. So still we are coming up with the same result. So you can just use this for your classes or for your something that you want to do. The other thing is, what about the Shear diagram and the moment diagram, right? So let's go and see what's going to happen here. Let's make it, check this. Define beam diagram. So Shear. Okay, sorry guys, there's edit, and let's show maximum and minimum annotation. You can write 140 and 66. But still, this one is negative in ours, this one is positive, right? As I told you, it's about sign convention. There is nothing different about this. As long as you're working with SolidWorks, you're going to get this thing. And let's check the, what we call the bending moment diagram. Let's check the maximum and minimum, and let's make this. So as you can see here, we have the same result, right? 217.8. Here we have 270.8. If you want to see, compare the results, you can just compare, and you can check this one, and you can select this. So here we have this, what we call the beam, the moment, sorry, the shear force, and here we have the moment diagram. You can just select this. Here is our today's tutorial, and if you have any questions, you can forward them in the comments below. And if you have anything that you want me to do, I'm happy to do that. So thanks, and have a nice time. Thank you.